So question 9 is your typical redox balancing kind of question. So I'm going to go through and show you how to do this specific example. And this will be for questions 9 and 10. They're going to be very similar in the way you'll set them up. So for this one, we're going to start out by figuring out what the half reactions are. And it's going to be XO, actually I'll do it down here, XO 1 plus gives X2 1 plus. And the other one is QH6O gives QH6O2. Now what we're going to do is balance the Q's and the X's. These are the elements being oxidized or reduced. This one's going to be a 2 out the front here to balance the X. The Q here is balanced. It's 1 and 1, so that's okay. So now we're going to balance the oxygens. Now if you look closely here, we've actually got 2 oxygens here, so that's need to be balanced with 2 waters. And down here we've got 1 oxygen and 2 oxygens, so this needs 1 water here to balance this one. Now over here we've got hydrogens, we've got 4 of them, so that needs to be balanced with 4 H pluses. And down here we've got 2 hydrogens and 6 hydrogens, that's a total of 8, and that's 6 there. So 8 versus 6, which means we need 2 H pluses here to balance the hydrogens on this side. The next thing we're going to do is balance the electrons. Now this one's a little bit tricky. We've got 4 and 2, that's a total of 6 on this side as charges go, and on this side we've got a total of 1. So what's going to need to happen here is 6 minus 1 is 5. We add the 5 electrons to the side that has the higher charge, which is going to be this one. So it's going to be 5 electrons plus all of that on the top reaction. On the bottom reaction, the total here is 0, and the total on the other side, on the product side, is going to be 2. 2 minus 0 is 2, and that means we add 2 electrons. Actually, I'll put that in a different place. And we'll add 2 electrons to this side down here. In the next step, what we're going to do is make sure that the electrons are evened out, which means I'm going to have to multiply the top by 2 and the bottom by 5. Now what I'm going to do is show you how this all pans out once I multiply through by all of that. So it'll be 10 electrons plus 8H plus 4XO 1 plus 2X2 1 plus 4H2O. Put an arrow there. Alright, so down the bottom here we'll have 5H2O plus 5QH6O, arrow 5QH6O2 plus 10H plus 10 electrons. Now the electrons will cancel, and now we can balance out the rest of this. As far as the H pluses go, that's 8 up there, and that's 10 down here, so we'll change that to a 2. For the waters, that's 4 up there and 5 down here, so I'll change that to a 1. Now I'm going to put all this together, and it's going to be like this. It'll be H2O plus 5QH6O gives 4, sorry, do that again, missed out on that, plus 4XO1 plus gives 2X2 1 plus 5QH6O2 plus 2H plus. Now, to make sure that we have indeed got the right answer here, we will check out how many hydrogens, oxygens, Q's, X's, and anything else we've got over here. So we've got hydrogens, we'll count those first on each side. We've got 2 here, and we've got 30 here. 5 times 6 is 30, so it'd be 32. Let's check the other side. We've got 5 times 6 is 30 plus 2 is 32, so we're good there. Oxygens. We've got 1 oxygen here, we've got 5 here. 1 plus 5 is 6, plus 4 is 10. However, on this side, 5 times 2 is 10, so we're good there as well. Q's. That's 5, so we've got 5 and 5, so we're good there. X's. We've got 4 over here, and we've got 2 times 2 is 4 over here. So it looks like everything's balanced up. Now let's look at the charges as well, just to make sure. We've got a total of 4 on this side, plus 4. And on this side we've got 2 times 1 is 2, plus 2 is 4. So the charges match as well. To complete this, we need the sum of coefficients. And it would be 1 plus 5 plus 4 plus 2 plus 5 plus 2. Remembering that the 1 here is implied. So add all those together and that'll give you the sum of coefficients, which will be your final answer.